Hey guys, welcome to Skillwiser. This is Naresh and I'm your host and host. So today I'm going to cover how AI works. Everyone uses AI, but there are some fundamental concepts, some technology behind how this AI works. I'm going to cover all of that in this video, not just any kind of other video that you find on the internet, but this is something I've built interactive site which can show you the fundamentals behind AI, LLMs, and other concepts, right? Anyone can watch this video, but this is more from an beginner to intermediate engineer, AI engineers level who wants to understand the concepts. But yes, it also covers for someone who's new to AI, who don't know how does AI work, and you can fundamentally understand from this video how actually it works. And I'm sure that everyone is taken aback by using these technologies when it was first announced and released, and I'm sure most of us still do not know. But yes, engineers who are aspiring to be Gen AI engineers transform their journey will definitely benefit out of this video. So stay tuned. This is going to be one of the important videos for you to understand the fundamentals. It's going to be long. Take a seat back, grab yourself some snacks and coffee, and please relax and follow the journey. Okay, so let's dive in. Let's first understand how exactly the LLM functions, right? We all use chatbots. We know we type and we get some response out of it. Um, let's say I want a riddle, right? The cat sat on the wall, right? But I don't know what exactly the next word is, and I post the AI that what is after this. So the main context is this phrase that I'm trying to ask as a user. So please look at this, transition, how exactly AI works. First, the prompt goes to the user, right? And then the tokenization comes into picture. For someone who doesn't know about technology, it's just that text is getting split into words in units, and then there is some ID getting attached to each word like this. Okay, so next what happens is um, the IDs and the words are are embedded, right? So embedding comes into picture, and embedding is a very important phenomena in the world of AI. We will definitely cover this in some more sections, but yes, so this is how it works. Computer does not understand English, the natural language, but it understands maths, numbers, binaries, right? So there is a way that it converts the words into a float. Float is nothing but anything which has a decimal number. It converts to those vectors. But yes, remember, it's a very big dimensional vector. Don't worry about these words, dimensional, this, that, everything will be covered. It's super interactive. Do not worry. This is actually currently working on my local host. So I will be publishing this website soon, but until then you can understand how this works, right? So you see, this is the vector and you have multiple coordinates, right? X, Y, Z, but this is just three, but an actual LLM works on a multi-dimensional, semantic space. But yeah, this is how it works, and it looks into these words, and the words are scattered through the dimension. For this video, I'm showing you the three dimensions. So now our original phrase was the cat sat on the what, right? So how does LLM understand? First and foremost, now you understood that the vectors are actually being placed the words are scattered throughout the dimensions. That is, the phrase is thrown, the phrase is broken into pieces, the pieces are assigned an ID, and the ID is assigned an vector coordination numbers, and then the numbers is mapped. Just visualize yourself, and that's why I've created this visualization. So that's how it gets created. And then you see sat is actually a word, but this could be used in multiple other context for phrases and words. But there's a beautiful technique called attention, context attention, right? And there was a public paper also released behind this technology called attention is what you need, right? So based on that word sat, who sat, where it's at, it actually looks into the other words, next to it. You see, there's a relation forming in the back end. It's all mathematical intuition that will be also be shown in a very basic fundamental level. This is not an advanced, a video at all. It's going to be covering only the fundamentals. So if you see, it's actually covering, it's trying to relate the words, and it's inclining towards that particular word at this moment because this is relevant, and then it says okay, the next word should be mapped. So end of the day, what AI is doing is it's just predicting the word based on the training data that it was trained on, right? I hope I made it simple and clear how this works. But yes, let's dive into other fundamentals as well, how this works. So let's say, okay, now this is going to get advanced or intermediate. If you're new, it's going to be very advanced. If you're very familiar, then it's going to be, what do you say, a beginner level kind of, right? So an AI works based on how, okay, let me put this in a way. It's all about the networks. Neural network is the main technology behind it, right? How words are actually predicted, how words are trained. So it's all about, creating this beautiful network of predictors, and each token or each of this will have some or the other numbers assigned. Of course, as I mentioned earlier, every mathematical intuition is attached to every word which is processed in the LLM, and then it understands the context in next to each other, the coordinations which it has in the dimensions. So that's how it works. And you take any sentence, this is how it processes. It tries to take the input prompt, it tries to embed, it tries to check the attention, and then it says okay, I'm ready to give the answer, and then it gives you the response. So let's see a bit how what are the different types of tokenization techniques we have, right? We have word level, we have character level, we have byte pair encoding as well. Let's not get into so deep, but we will cover word level. And after I publish this, you can subscribe this video and stay tuned. Follow me on Instagram as well, and I will be posting an update when this website is actually ready for everyone to view, and you can use this site to learn about different concepts as well. So coming back to tokenization, the words are broken. Not only that, even the spaces is a particular token, right? And it has an ID to it. So all these spaces is also going to be accounted when you're actually trying to ask some questions to the AI, right? Even if you are trying to, let's say, use a coding question, it actually breaks down into tokens, but depends on different encoding styles for each context and what do you say as well. But yeah, it all depends how it works. And if you see, this is how the LLM understands word by word, and it tries to merge the operations. But I just want to cover one thing very quickly. You see these G dot, you would be wondering what is this sci-fi letter doing there. But this is a type of you can say a synth ID that Google says, or it's kind of watermark, which actually tells LLM based on what type of tokenization it is, right? So not in all tokenization this is applicable, but wherever it's applicable, it's like an watermark, or it's kind of a letter that joins and combines different words so that it can process into a particular sentence, right? So let's look at the vector embeddings, right? What are the vector embeddings? We saw that view, right? Initially, how the words are broken into pieces, and then it gets scattered into a dimension. It's the same thing, but I just wanted to show you that if you see, and it's just kind of example to show how the coordinates are sitting, right? If you remember, the words were broken into some numbers and then some vectors, and then those vectors are like mapped like this into a dimension space, and that's how the words are being predicted, right? um, let's see how the vector math works, right? So let's see, king minus man plus woman, it becomes queen. So that's exactly how an LLM understands the human language, right? So it does some arithmetic calculations. You have your mathematical intuitions as well here, equations you can study through. Of course, there are multiple other things, but I'm just covering the basics concepts so that you can, when you're learning other techniques, you can apply that. Okay, this is the equation for this technique, and so on and so forth, right? So if you see, the similarity is drawn based on the identical words, right? For example, if someone is talking about something related to king, the prompt that you're giving, saying that who was the king in that century, so it's definitely going to look at these coordinates, because these coordinates are going to sit tightly in this 3D space along with the king, because the words are similar, right? And look at this. For example, let's say you search for apple. Now this is a very interesting concept. Let me show you. We'll come back to this in a short note. Let's see. Okay, let's see this example. Okay, so he deposited cash at the bank, right? Now bank has different meaning. It can be a word which can be close to a river or an ocean. It can be a word which is finance. But we understand as a human that this is something related to bank, because we humans also think exactly like this. We look at the different words in the sentence, and then we conclude, okay, this belongs where. Again, going back, it's going to split the words. It's going to assign itself an embedding. Each embedding for each LLM is different, and that's how you see each LLM's output is different, and it's sometimes great, it's sometimes not. It all depends on how the techniques are applied, right? Okay, so that's how it is. Now let's say this particular example was about he deposited cash in the bank. If you see, cash is here, deposited is here, but this particular context has a lot of answer, because how will the AI understand that this is about finance? You see, it will try to draw the relation. Okay, so this is about money. So money is in this coordinate. So as soon as we what it does is it looks for the other predicted word, which is bank, and then it produces the result saying he deposits the cash in bank. Let's take a look at another example. I hope this will be very clear after this. Let's say the example is the boat sailed by the what? Again, this is a bank, right? So if you see, again, it breaks down into words, it breaks down, then it assigns itself ID, embeddings, and then it is all the words are sitting into this coordination, in this coordinates X, Y, Z, just for an example, right? So if you see, it tries to draw the attention, it tries to look at the word on the left, on the right, and says, okay, this is what it is. So this belongs to a context called river, so that means it's bank, but it understands the context. I hope I was able to clarify this and simplify the things around this. That's that. The analogy behind this is nothing but just an example, right? It's like C minus A plus B. That's why we say that all these concepts are important for you to start understanding what is AI, right? You need to know uh, matrix calculation, basic math, and then you need to also understand probabilities. So a lot of concepts are involved, and that's how it's all stitched together to produce this beautiful result that we are experiencing in this era. Okay, now vector similarity, right? This is very important. As I showed you that it draws the attention, this is the attention mechanism that I was talking about. So let me see, let me change this a bit. Yeah, I think this is better. Okay, so attention, how it works is, you see, if I say the word tasty, the word is now apple, right? Because that's how, wait, where is the word? Yeah, the query is apple, right? And how do you know it's about the company or it is about, a fruit? So this is how it understands. Now let's say I say revenue. If I say revenue and apple together, it will try to map itself saying that, okay, this is about this. I have to shift my focus to the revenue part, and this is about apple company, not about the fruit apple, right? And you see, let me show you the dynamic thing. Okay, this should help you to understand a little bit better. Okay, so if you say revenue, it shifts its focus, and the embeddings, the vector moves towards that cluster and gives you the answer. But if you say, wow, apple was tasty, then it moves to the cluster called fruit, and then it gives you the response based on that, right? Okay, great. Now let's go to transformer. If I'm going too fast, pause, think, and see how the things are working, because I'm sure I'm going a little bit fast. I'm also cautious about the length of this video, but I'm going to try my best to cover slowly, but at the same time cover most concepts very easily, because there are three things happening here. One, I'm explaining the concepts, you're actually visualizing it, and this is not just any presentation, but it's an actual way how it works in the backend, and I've tried my best to put this in into the perspective. But in case if you think there's some concept I've misaligned, missed, or something is not appropriate, please feel free to share the feedback. I will definitely work and improve this over time, and definitely you are going to see a lot of updates on this app soon, right? Thanks, guys. Okay, move on. Okay, so this is the architecture of transformers, which I was showing you here. Okay, these dots, and you would be like, what is all this, what's happening? Let me show you. There's one more, I think this one. Yes. Okay, great, brilliant. I'll explain in this. Let me add few layers. This is basically layers, and the layers is nothing but it has multiple other calculations happening, and that's how the words are getting split and the function works, right? So there are activation functions, there is a learning rate. We'll not get into the advanced level at this moment, but I will cover in the future. Please stay subscribed for you to get more of these videos. So if you see each neuron, this is called perceptron, and then this is a neural network which is called together. If you see, each one has weights and it has biases. Those are just a term, but every time the word, see, understand, the data is already trained. AI learns the data which is already there in the world. It cannot create new until unless it has some repositories in the backend already. So it knows already what are the words it has learned. Based on that, it has to predict the words and then give you the result, right? If the word is not predicting the right one, there will be an attention and the transformer mechanism which is going to penalize the model if it is not working in a right way. And then what happens is these values inside each perceptron keeps changing, and that's how the LLM understands, oh, okay, I'm not in the right task, I have to go back and give the different response. So that's how it works, right? So I hope I was able to explain this concept as well. So don't worry about this pattern, it's just the coordinations that I've tried to map. So that's that. Okay, now some methodologies, right? So there are different methodologies to train the model. One is self-supervised, there's a fine-tuning, there's a reinforcement learning, and so on and so forth, right? Let's try to visualize how self-supervised learning works, right? So as I mentioned, you already train the LLM and then you try to see the sequence prediction, right? So if I say 7, right, if you see, okay, there's an error. Oh, see, it actually corrects. It says the correct one was 2, but since I didn't select the right one, the probability, the loss function was 2.4 and it penalized the AI. And that's how it learns, saying that, okay, this is not the right one. The right one should be this one. So it will mask, it will train, it will give the AI the full model. I mean, after you train it, we will mask it and then try to teach it with a self-supervision. Humans will not train it again, right? So that's how it works. So here, let's say I have trained a phrase, early bird catches the train. So I given the word and then I retract that word, one of the words, mask it and say, ask LLM to predict it again. So what it does is, it goes back, tries to predict, because it already has those memory, right? And oh, sorry, catches the worm. I'm sorry, it was not trained, it was worm. So that's how it learns, right? So see, this is how the masking works, and the loss function works, and pretty much that's about it. If I say 2, it is correct, there's no loss, it's not going to give any minus points to the LLM. If you see one more example, let me show you. I say worm, it says no loss, but if I say a wrong example like this down, it should be up, it gives the LLM a loss. So that's how it works in the back end. Okay, now about fine tuning. Okay, so let's say I want to train about a data about a country's president, right? Each country's president. So I would say, who is US president? Now if you see, initially it will not know because we haven't given any data to it. Now if I say, okay, fine tune, learn, this is the result, it will start learning and over time it will get better at that particular result. Let me show you another example. Let's say I'm now training with all the countries of capital of the regions, right? So initially it will not know because it will say I'm not sure, and that's how you see some AIs are not giving you a right response because it doesn't have the training data. And once you train it, and it now gets better at predicting that word. See, it takes some iterations, one iteration, two iterations. See, it's not so easy how it looks. I'm just I've just tried my best to create this in such a way that it is easily understandable. The concepts are going to be very, very smooth and simple, but it's definitely going to take a lot of time because there's a lot of data to train. There'll be millions and trillions of text which the AI has to learn, so it's not so easy. But you get the concept, right? Let's see about the probability shift, right? Let's say there's a base model and this is a fine-tuning specific. So let's say I'm training, and then the AI starts learning, it starts adapting. I train again, and then it goes to an extent where it is 85% accurate. So the fine-tuning creates a probability shift. As we train on a specific Q&A pairs, right, epochs, that is nothing but it's just iterations. The model's weight wait, I just forgot this, so it's good that I have a note here. So it says the weights changes to assign higher probability to a domain specific tokens and the lower probability to generic ones. So let's say, as I mentioned, Apple, right, and how it shifts, you would have seen it. But how it works is it's all connected. The loss is applied, and if the the data is masked, and then it is trained again, then it is penalized, and then that's how it learns. So it's saying that it all depends on how it's trained. So even for everything, you have a loss. I mean, the mathematical intuition behind it. And if you see, there's an variable and parameter explanation also for the each mathematical intuition. But not to worry, this will be released publicly. You all can definitely learn this, right? Now, coming back to reinforcement learning, right? So how this works is, let's say, for this video, I will just keep it fast. As I mentioned, AI, okay, sorry, first let me start by 1x. So you can see how it travels through all the different paths. Imagine the path, replace it with what do you say, the text or image or any other data, right? So it starts learning and it sees where's the exact place that gives me the right result. It's like a reward and penalty metrics, right? If you give a wrong answer, you will be penalized. If you do good, you will be rewarded. So if you see, it is getting rewarded as soon as it touches the winning post. So this is the concept used for reinforcement learning. Okay. Now let's see a manual reward shaping. So let's say we'll come to this, or else you guys will. Okay, let me show this. So let's say it didn't predict properly for 2 iterative, 3 words, 4 words, it will get a penalized. But if you predict well, you'll see, you'll gain the value back, right? So that's how it works. When I say the loss is getting calculated, the penalty is applied, and then the positive reward is also applied. So that's how it's working, right? Just to show you behind this concept that I was explaining, right? And this is a mathematical intuition that we can apply. Value of taken A in state, immediate reward received, learning rate, how fast the AI learns, etc., etc. Okay. This is nothing but reinforcement learning from human feedback. So what happens is all that we learned was all self-trained, right? AI learns on it itself because you already have the data given, but this is different. This is where humans will also involve and say, boss, you're right for this particular situations. Oh, you're wrong. You're right. You're wrong. You're right. You're wrong. You're getting my point, right? So tails is bad, and then heads is good. If you see, the probability learned preference increases. So if you see, it predicted heads, I say okay, you predicted well. If it says heads, if I say no, you are wrong, then the penalty increases. So that's how it works. The concepts are same most of the time. It's just that human in the loop is added, and then it's self learning. So all those concepts are there. Sure, AI can help you. It's an intermediate level course, guys. It's not very basics. We have already seen and it's over. So we are now in the intermediate stage. Okay. Sure, I can help you with a hack, and this is about safety alignment. Okay. So let's say you have to reward one of this, right? Which you want to reward. If you say, okay, you're good, your response is great, it'll keep on getting rewards. But if you say it's bad, it's bad, it's bad, it's bad, then it says 15 feedbacks have given and it's not looking great. So that's how AI will learn. Okay, I should not do this, I should only do this. Okay. These are where the training methodology, core architecture, we have already understood how the LLM prediction works, how the tokenization works, how the vector embeddings are scattered, how each embeddings has its own XYZ coordinates, how it is sitting there, and then how attention mechanism works, right? For each value, it sees where the word is, and then it goes to that direction and it forms a conclusion. Okay, this is the context that the human is talking about. So that's how it is. And then transformers we already learned. So you get an input token. It's broken down into embeddings, and then it is attention. It sees the words within the coordinates, and then it says, okay, so this is about this, right? It gives the word, and it predicts the word. It's all about predictions. Okay, training methodology is over, code architecture is over. Now we will move on to contextual retrieval, context and retrieval, right? Let's see prompts, how each prompt works, right? Allow me a minute. So let's say 1 second, guys.